There were two more questions on that assignment that looked at the question of dealing with a velocity field as a function of the x, y, and z, and asking you to find out some things about those velocity fields. So complete only questions 7 and 8. They were bonus questions, but they're required on this assignment. And further, is the flow described in question 7 incompressible? So let's check out question 7 first. A Cartesian velocity field is defined as v equal to 2x I hat plus 5y z squared j hat minus t3 k hat. Find the divergence of the velocity field. Well, okay. So that was v as a vector equal to 2x I. That hat, I think, means the I vector, the vector in the x direction, plus 5yz times 5yz squared in the j direction, the component in the y direction, minus t, guess that's time, cubed in the k direction. And it asks us, what's the divergence? Well, if you remember from class, the divergence is this gradient operator operating on some vector, so on the velocity field, and if v can be broken down into components ui plus vj plus wk, then this is just equal to di-u, di-x, plus di-v, di-y, plus di-w, di-z. So if I take those di-u, di-x, well, u is equal to 2x, so di-u, di-x is 2. Di-v, di-y, this is the v component multiplied by the j vector, so 5yz squared, derivative with respect to y, everything else held constant, that'll just be 5z squared. So plus 5z squared plus di-w, di-z. Well, if w is t cubed, that doesn't change with z at all. So di-w, di-z is equal to 0. So the divergence is 2 plus 5z squared, which in general is not equal to 0. But incompressible continuity says the divergence of velocity has to be equal to 0 if the flow is going to be incompressible and conserve mass. So di-u, di-x plus di-v, di-y plus di-w, di-z must be equal to 0 for an incompressible flow. Therefore, the question we asked, this flow isn't incompressible. Something's happening here. Things are expanding or compressing, one of those. In any case, not incompressible. If it was incompressible, the divergence would be equal to 0. And that pretty much answers question 8. Why is the divergence of velocity important in fluid mechanics? Because the divergence of velocity is equal to 0 when the flow is incompressible. It tells us something about where mass is going and where it's coming from. So divergence is the incompressible continuity equation.